Hello everyone, today we will introduce a powerful tool for the electronic component characteristic test, the source measure unit, or SMU, which combines bipolar DC source and high-resolution digital multimeter. This video will explain what the SMU is, its applications, the key features of GSM-20H10, and how to get the detailed information.
What is SMU? SMU combines the DC power source and digital multimeter into one box. Firstly, the DC power source in the SMU is a bipolar, four-quadrant power supply. The conventional DC power supplies only generate voltage and current in quadrant 1. Some power supplies can also sink current like a load. For this type, only positive voltage is supplied. Therefore it is a two-quadrant source. For the bipolar DC power source, a single channel can output and sink current, and supply both positive and negative voltage to DUT, so it works in four quadrants. The digital multimeter in the SMU is a low-current, high-resolution, and high-speed digital multimeter. The SMU brings great advantages over a power supply plus a digital multimeter. First, it takes less space than the power supply in DMM. And its interconnection of source and measure units significantly simplifies the wiring of the power supply in DMM. As well as when the measure takes place by remote control, the interface cable connection is much easier. Furthermore, you don't have to rewire when switching the voltage and current measurements. Sometimes people also call SMU like precision source measure units, or DC voltage current source monitor.
Now we will introduce some applications of SMU, including the characteristics test of diode, solar cell VI curve, and MOSFET. Battery charging and discharging test, precise low and high resistance tests. Finally is the LED thermal resistance measurement. Typical LED and diode VI characteristics tests include forward bias and reverse bias. For the forward bias test, the SMU source outputs a positive voltage, and the meter uses the 4-wire measurement to achieve a more accurate voltage measurement. For the reverse bias test, the SMU source outputs reverse bias, and the SMU meter's low current capability can perform the leak current and breakdown voltage measurements. The solar cell VI characteristics test. In this case, the SMU source acts as an electronic load, and the meter uses the 4-wire measurement to measure the short circuit current, VI curve, and the open circuit voltage. The VI curve's voltage and current product result in the power curve. The maximum power point, PMP, occurs at the curve turning point, where the current of maximum power and voltage of maximum are defined. Solar cell efficiency equals the maximum power divided by the open circuit voltage and short circuit current product. The MOSFET characteristics tests include drain curve, threshold voltage, transconductance, gate leakage current, drain leakage current, breakdown voltage. Some of the tests need two SMUs. Drain curve is the most critical characteristic while using a MOSFET. The test procedure. First, use SMU1 to set an initial gate-to-source voltage, sweep VDS with SMU2, and measure the drain current to obtain the curve. Then set VGS to the next value, and sweep VDS to obtain the different curve. Repeat the reset VGS value and sweep the VDS procedure to obtain the drain curve family. The gate threshold voltage is the gate-to-source voltage when the minimum current flow from drain to source. Test steps. First, set drain to source voltage to a particular value with SMU2, which the minimum drain current will occur. Then sweep the gate to source voltage with SMU1 until drain current reaches the minimum value. The gate to source voltage is the gate threshold voltage. The transconductance represents the signal gain of a MOSFET. The test steps are: set the constant voltage over drain and source with SMU2. Sweep gate to source voltage with SMU1, and measure the drain current by SMU2 current meter. Transconductance equals delta drain current divided by delta gate to source voltage. Gate leakage current is the current between the gate and source when drain to source voltage is 0. The test steps are, at first, short drain and source, and then, sweep gate to source voltage over the specified range, measure the current. Drain source leakage current is the current between the drain and source when gate to source voltage is 0. The first test step is to short gate and source, sweep drain to source voltage, and monitor the leakage current between drain and source. Drain source breakdown voltage is the voltage when gate to source voltage is 0, causing a significant drain and source current to flow. The test steps are, short the gate and source first, sweep the drain to source voltage until drain current starts to flow and reaches the specified value. That voltage is the breakdown voltage. In the battery charging cycle test, the SMU source acts as a voltage and current source, and its voltage is higher than the battery voltage. As a result, the current flows from the SMU to the battery. In the battery discharging cycle test, the SMU source acts as a load to sink current, and its voltage is lower than the battery voltage. As a result, the current flows from the battery to the SMU. The SMU can measure low resistance, such as conductor resistance. The SMU sources a current, and the meter employs 4-wire measurement to measure the voltage to obtain resistance. On the other hand, the SMU meter can also measure the insulation resistance by its low current measurement ability. The SMU sources a voltage, and the meter measures the current to obtain the insulation resistance. Thermal resistance is critical for high-power LED. The lower the thermal resistance, the less heat is generated. Measure steps are basically first, use the thermoelectric cooler to set the LED sample temperature at Tj. SMU outputs a small current Is, small enough to not result in further device heating, typically about 1/50th of the nominal device current. Second, set SMU outputs the pulse current Im, typically the nominal current of the device with 0.5 milliseconds, 0.25% duty cycle. At this condition, record the voltage value, Vm. Then alter source output current from pulse to DC. As a result, both LED voltage and temperature will vary. Next, feedback the voltage and control the thermoelectric cooler to tune the LED temperature to stabilize the voltage value to Vm. Record the temperature as Tm. Thermal resistance equals the temperature variation divided by LED power, the product of voltage and current.
Here we will introduce the key features of GSM-20H10. There are two ranges of the GSM-20H10's source output. For the plus-minus 21 volt voltage range, the current is plus-minus 1.05 amps. For the plus-minus 210 volts voltage range, the current range is plus-minus 105 milliamps. The power capacity is 22 watts. GSM-20H10 source provides 4 sequence output modes: linear stair, logarithm stair, source memory, and custom. With these output modes, users can quickly generate the output as wanted. The total number of the sequence points is 2,500. GSM-20H10 source equips the overvoltage and overtemperature protection functions. GSM-20H10 meter provides high accuracy resolution features. For example, it equips 0.012% basic measure accuracy and 6.5 digits resolution. GSM-20H10 meters sampling speed is variable. Therefore, users can select the sampling speed from 0.01 PLC to 10 PLC as required, where NPLC stands for the number of the power line cycle. For instance, if AC power frequency is 50 Hz, 1 PLC means 20 milliseconds, 2 PLC means 40 milliseconds, etc. Source delay measure cycle. The source output's initial state might be unstable. If the meter's measure starts after the source output, users can set source delay to start the meter measuring after the unstable period to obtain a stable measurement. GSM-20H10 source delay ranges from 0 to 9,999.9990 seconds. In addition to 2-wire, GSM-20H10 provides 4- and 6-wire resistance measurements. 4-wire measurements eliminate the lead resistance effect to achieve accurate low resistance measurement under a high current situation. 6-wire combines 4-wire connection and guarded ohms feature to eliminate the effects of internal parallel resistances to achieve the low in-circuit resistance measurement. GSM-20H10 meters display digit is variable. Therefore, users can select the display digit among 3.5, 4.5, 5.5, and 6.5 digits as required. GSM-20H10 provides built-in 3 categories, 11 groups of pass, fail limit tests. GSM-20H10 provides 5 built-in calculation functions: power, offset compensated ohms, voltage coefficient, varistor alpha, and percent deviation. Please refer to the operation manual for the details. GSM-20H10 provides complete remote control interface ports. Include RS-232, LAN, and USB TMC, they are all built in as standard. TFT LCD, digital keypad, and RTC, the real-time clock. The TFT LCD, and the digital keypad provides users with a more friendly input method. Finally, the RTC clock generates the timestamp with each storage file.
For more detailed information, please visit our website. Thank you for watching this video. Looking forward to seeing you soon. Bye bye.